Hi, my name is Sebastian Niño Sañosa, and in this video, I'll be tackling about properties of a group. Properties of a group. A group is a set of objects with one operation that satisfies the following four properties. Number 1 is the set is closed with respect to the operation. Number 2 is the operation satisfies the associative property. Number 3 is there is an identity element. And number 4 is each element has an inverse. The set is closed with respect to the operation means a set is closed with respect to that operation if the operation can always be completed with elements in the set. For example, the set of even natural numbers 2, 4, 6, 8, and so on is closed with respect to addition because the sum of any two of them is another even natural number. For example, even integers, -6, -4, -2, 0, 2, 4, 6. -6 plus -4 equals -10. -10 can be seen below as part of even integers. -2 plus 2 equals 0. 0 can be seen below as part of even integers. 6 plus -2 equals 4. 4 can be seen below as part of even integers. 6 plus 6 equals 12. 12 can be seen below as part of even integers. Because all the answers can be seen in the even integers, that's why it is a closed property. The operation satisfies the associative property, means an operation is associative when you can apply it using parentheses in different groupings of numbers and still expect the same result. The two big four operations that are associative are addition and multiplication. Example: the associative property of addition says that no matter how a set of 3 or more numbers are grouped together, the sum remains the same. For example, if we group the numbers 3 plus 4 plus 5 as 3 plus open parenthesis 4 plus 5 close parenthesis or open parenthesis 3 plus 4 close parenthesis plus 5, the sum that we get from both the sets is 12. There is an identity element, means identity element. An identity or neutral element is an element of a set that when combined through a binary operation with any element of the same set leaves the element with which it is combined and changed. There is 4 identity elements: additive identity, subtraction identity, multiplicative identity, and division identity. Additive identity. With regard to addition, the identity element, also known as the additive identity, is 0. This applies to the following numerical sets: the set of natural numbers n if 0 is included in the set of integers z, the set of rational numbers q, the set of real numbers r, the set of complex numbers c. For all these sets, given any number n plus 0 equals n equals 0 plus n. For example, 9 plus 0 equals 9 equals 0 plus 9. There is no identity element for subtraction. Subtraction is not commutative. It means that given any number n, while it is true that n minus 0 equals n, it is not true. However, that 0 minus n equals n, for example, 7 minus 0 equals 7, but 0 minus 7 equals negative 7. Therefore, the double condition that makes 0 the identity element for addition is missing for subtraction. Multiplicative identity. In that case of multiplication, the identity element, also called the multiplicative identity, is 1. It applies to the set of natural numbers n, the set of integers z, the set of rational numbers q, the set of real numbers r, the set of complex numbers c. For all these sets, given any number n, n times 1 equals n equals 1 times n. For example, 9 times 1 equals 9 equals 1 times 9. There is no identity element for division. Division is not commutative. It means that given any number n, while it is true that n divided by 1 equals n, it is not true. However, that 1 divided by n equals n except when n equals 1. For example, 7 divided by 1 equals 7, but 1 divided by 7 equals 1/7. Therefore, the double condition that makes 1 the identity element for multiplication is missing for division. Each element has an inverse, means a set has the inverse property under a particular operation if every element of the set has an inverse. An inverse of an element is another element in the set that, when combined on the right or the left through the operation, always gives the identity element as the result. Example. The set of integers has the inverse property under the operation of addition because it has the identity element 0, and it is true that for any integer x, x plus open parenthesis negative x close parenthesis equals 0 and negative x plus x equals 0. So negative x is the inverse for x in the set of integers under the operation of addition because it gives the identity 0 as the result whenever it acts on x from the right or the left. Here is an operation table for the set A, B, C, and the operation. To find any inverses that might exist, first, we look at the table and find any place where the result of an operation on two elements is the identity element A. From the table, we can see that A operation A equals A, B operation B equals A, C operation C equals A. So every element has an inverse. A is the inverse of A, B is the inverse of B, C is the inverse of C. In this set, every element is its own inverse. So the set A, B, C under the operation defined by the operation table above does have the inverse property. Thank you for watching, and I hope you learned a lesson from the video.